Hello and welcome to VisualCAM MILL 2016 for SolidWorks. In this video, we discuss and demonstrate the new Xpress configuration while programming 2.5-axis, 3-axis, and hole machining operations on a 3D part model. VisualCAM MILL Xpress is ideal for makers, hobbyists, and students looking to get familiar with CAM for the first time. If you're ready, we invite you to sit back and enjoy the demonstration.
Today we're going to take a look at our VisualCAM 2016 for SolidWorks Express configuration, which is now being offered in the MILL module. VisualCAM 2016 for SolidWorks is a gold certified CAM partner product, and this runs in SolidWorks 2010 all the way up to 2016, and it's available in both 32 and 64-bit platforms. You can run the application by starting up your SolidWorks application, and VisualCAM plugin will automatically load in SolidWorks. So as you launch SolidWorks, and from the Get Started dialog, you can select Run CAM Demo, and under the Product Configuration menu, you will now be able to select Express as the configuration and then select MILL. This automatically loads the CAM plugin in SolidWorks. You're now ready to go ahead and import your file or load your part into it. Locate your SolidWorks part and then pick Open. Or you can import any file formats that can also be imported into SolidWorks, and we can generate toolpaths using the MILL module. You will notice that once the part is loaded, the VisualCAM tab appears under the Command Manager in SolidWorks, and your machining browsers appear right next to your Feature Manager design tree. So you can switch between the Feature Manager design tree and the VisualCAM tab by a single click of a button. You'll also see the VisualCAM menu under Tools and VisualCAM. If you're running SolidWorks 2015 or newer, in older versions of SolidWorks, the VisualCAM menu appears right next to the Tools on the main menu bar. Now today we're going to be taking a look at what's offered in the Express configuration. Express configuration offers 2- and 3-axis milling in addition to hole machining. Under the through axis methods, you'll have access to facing, pocketing, profiling, and engraving. The 3-axis would include horizontal roughing and parallel finishing, and the hole machining includes drilling. Additional types of methods for 2-axis, like high-speed pocketing, chamfering, V-carving, hole pocketing, hole profiling, T-slot machining are offered starting with the standard configuration. So the Express is a new addition to our existing line of configurations. So this would be your entry-level configuration, which offers basic 2- and 3-axis milling methods.
Hey, Uday, I wanted to jump in here and add something real quick. For those users who currently have VisualCAM for SolidWorks product already, but they may be interested in looking at the Express version maybe as a second seat or maybe in another related facility, they can look at the Express configuration simply by releasing your license and restarting the product, and you'll get that Get Started dialog where you can set the configuration. Is that correct?
That is correct, once you have the latest service pack installed.
Right. Okay. So even if you got the product, you can still take a look at it if you're interested in seeing what it can do, or somebody else in your facility is interested. Okay.
So, now the VisualCAM's interface has the machining browser right here at the top, and then the machining objects browser right underneath it. Then the machining operations browser provides you access to the 2 main tabs, Program and Simulate. Under the Program tab, you have 3 main groups: Machine Setup, Stock, and then the Machining Operations. The Simulate tab offers you cut material simulation, or also known as verification. Now right underneath the Machining Operations browser, you'll find the Tools tab, which is part of the Machining Objects browser. Now if this tab is not visible, you can click on Tools and Machining Objects to toggle the visibility of the Machining Objects browser. Now the Tools tab allows you to create tools. You can load tools from your library, save tools to your library, and also select tools from your library. Now by default, you will have access to an English tool and a metric tool library that ships out with the product. Now, the following tool types are included in the Express configuration. These are ball end mills, flat end mills, corner radius tools, V-mills can be used for engraving, and drilling tool. Additional tool types like chamfer tools, taper tools, face mill, fillet mills, lollipop cutters, user-defined tools, tap or reverse bore tools are offered starting with the standard configuration, so you can upgrade to the higher configuration if you need more tool types. Now on each of these tool types you can specify your tool properties in here, assign your tool numbers, set your feet and speeds. The built-in feet and speeds calculator is also included in the Express configuration, where you can establish feet and speeds based on the stock material, tool material, and the tool properties you're working. So all of these tools types can be defined. You can have multiple tools defined under each tool type as you see it in here, and you can save and load those tools from the library. Now once we have a part designed or imported into SolidWorks, the typical workflow in here is to go over to the Program tab and then go over to the Machine Tool Setup. Now in this dialog there's two tabs. Now the first tab allows you to establish the orientation for machining. So this will allow you to rotate your coordinate system or reorient the coordinate system that is suitable for machining. So in this particular case you'll notice that by default the orientation of the machine tool coordinate system is in the same orientation as the world coordinate system that's established in SolidWorks, and by default the origin is at the origin where you have in SolidWorks. Now if you need to change the orientation, now for example if you're looking to just program the features on the bottom of these parts, or where you may want to just do a pocket programming, you could change the orientation in here by rotating your coordinate system using these controls, or you can even use select a surface to pick a surface and it'll automatically establish the z-axis to be normal to the surface. So with the Express configuration you will be able to establish one coordinate system for machining your part. So you can establish the orientation. So this is one orientation that you can establish for programming a given part with the Express configuration. If you need the option to create additional orientations, we call them as multiple coordinate system setups. Those are offered in the Pro and Premium configurations of the product.
So the part's not being moved though in SolidWorks, correct?
The coordinate system, the core is being transformed or translated to have it oriented the way you want to have the part to be set up for machining it on your CNC machine tool.
Okay.
Now once you establish your machine tool coordinate system, the next tab allows you to establish the machining process. The number of axes is set to 3, so this would be applicable for both 2 and 3 axes. Now if you have a need for programming 4 axis or 5 axis, those are available in the higher configuration. The 4 axis is available starting with the Expert configuration. Index 5 axis is offered in the Pro, and simultaneous 5 axis is offered in Premium configurations.
Do we have the latest online help that shows the configurations in it?
Yes, we do. So you can click on the Help button, and as you go down to the Welcome group under Configurations, you'll see the entire list of configurations right there. Summary of configurations, and you can access the help system by just clicking the Help button from the machining browser, or you could go into the help system by selecting the help button from any of the CAM dialogues. Now the next step is, once you have the machine tool set up, you can see that the machine is set up as 3 axes. The next step is to select your post processors. The VisualCAM's mill module includes posts for over 225 plus different machines and controllers, so which covers a wide range of CNC machines out there. The list of posts what you see in the Express configuration is exactly the same as what is offered in the other higher configurations. So you have access to the entire list of posts that's included in all of our configurations. The posts are either listed by the name of the machine tool or a combination of machine and in a controller name. And the post processors can also be edited by selecting the edit button in here, and you can use the post generator to go and edit and configure your posts. Newer posts can also be created from using one of the existing posts, and newer posts can be created for any machine tool that can read standard GNM codes.
Yeah, and also I just wanted to mention that we're always here to help you. Yeah, if you need to make edits to your post, it may seem daunting at first, but you just contact us, we'll help you.
Once you set up the post processor, the next step is to select your posted file extension in here. You can select that and then you pick OK, and there it is. The next step is you want to define your stock material. So you can go down to stock and then pick box or part box stock. So the Xpress configuration offers the rectangular stock or the box stock, and in the case of box stock you can enter in your length, width, and the height, and the system automatically determines the minimum stock extents based on the part that's designed in SolidWorks. So you can specify your length, width, and the height. This is one of the ways how you can establish your stock geometry. Alternatively, you could use the part box stock in here, where you can specify an offset in X, Y, and Z to have the box stock slightly larger in X, Y, or Z, or all three axes. So these are the two stock definition types that are offered in the Xpress configuration. Additional stock types like cylinder stocks are offered starting with the standard configuration. If you'd like to be able to create a stock which is a true offset of the part itself, that's known as part offset stock. It's offered in the Pro. You also have an option to do a stock by selection, where you can design your stock and then select it from your feature tree and do a stock from selection. Then those are offered in Pro and Premium configurations as well. So once you've established your stock in here, you can toggle the display of the stock by selecting Stock Visibility from the machining browser, and you'll see that the stock information is also updated under your machining job. The next step you'd want to do is align your stock to the part. So you'd go to Align and choose your alignment. So in this particular case, I'm going to align the Z to the bottom, since the bottom of the part is planar, and I'm going to set the XY to be at the center. So you'll notice that the stock is centered around the part. So if you go normal to the view, you'll see that the stock is being centered around the part, right? And once you established your alignment, you can then go select your material in here. Selecting the material helps you in computation of your feet and speeds, and also you can apply the material texture during simulation. So you can click on material texture, and this actually applies a texture on top of the stock blank right there. You can toggle the texture visibility on and off by selecting the texture visibility button. The next step is to establish your origin, or your program 0 or your work 0. This is typically set as a reference point on your stock blank, where all your coordinate motions are established based off this origin. This can be done by using work 0. By default, the origin is set where the origin is in SolidWorks. If you'd like to pick a specific location, you could use pick, and you can go snap to a vertex, or you can go pick a point, or you could use set to stock. You can pick the 0 face to be the highest Z, mid Z, or lowest Z, and a stock face. You can pick the corner in here. You could go to the southwest corner. You could be using the center. So this basically allows you to establish your work 0. On some machines, it's also known as work coordinate offset. It could be a G54 or a G55. If you'd like to output this information, you can select it right in here and then pick generate. And there's your work 0, and automatically appears in your machining job. Now in the next step, I would like to go ahead and face the top of the stock blank, so to bring it as close as possible to the finished shape of the finished height of the part. So the first step I'm going to do is, in order to face the stock blank, I'm going to go ahead and create a sketch that represents the extents of the stock in here. So I would go into the Sketch Modeling tab in the Command Manager and insert a sketch, and I'm going to use a rectangle, and we'll pick two corners, and I'm just going to go ahead and throw in a sketch right in here in SolidWorks. And there's my sketch right there. Now I'm ready to program a toolpath, so we'll go over to 2-axis, and with the Xpress configuration you have access to facing, pocketing, profiling, and engraving. If you need additional 2-axis methods, you could look at the feature list, and they're offered starting with the standard configuration. You can upgrade from Xpress to standard. We'll go to facing, and you now have the option to select your part region. You could use select curvature region. You can select the sketch, or you can even select a chain of face edges. I'm going to right click and use select chain to have the chain of sketches selected right in here. Accept my selection. I would then go into my tool tab to select the tool for it. So I'm going to use a 3/4 inch end mill for facing it. Now if you'd like to use a face mill or any form tool, you have those options available starting with the standard configuration. The next step is to set your feeds and speeds in here. We're going to use load from tool or you can use the feeds and speeds to be computed based off the file. We can set the clearance. By default, it's set to automatic. The next step is to establish your roughing parameters. You have your tolerances in here, your stock allowance. You can specify your cut pattern. You can use offset or linear cut pattern. I'm going to go with the linear pattern for this example. Specify your cut direction. You can set your angle of cut, which represents a direction. By default is 0, which means it will run parallel to the defined x-axis for your machine tool coordinate system. You can control your step over in here. On the cut levels, you can specify the geometry location. So the sketch what I've created here is on the top face of the part, so I'm going to pick as at bottom. And I can set my entry and exit parameters in here. Now additional options like advanced cut parameters are offered in the standard and higher configurations. Selecting generate will create your facing toolpath, and there it is. You can now go to the simulate tab, select the machining operation, and hit play to run the verification.
So the rectangle sketch that you added, that was just for an XY containment? Is that what?
That is correct. That would be the part region for the facing toolpath. Now, had I selected the face edge around the actual part, I wouldn't have been able to mill all the way through to the entire stock material.
Right. It's the containment perimeter, I guess. Okay.
Right. Now, one of the nice features we have in our standard configuration is a method called 2-axis and roughing. So in that method, it will automatically take into account the extents of the stock, so you don't have to create the sketch. So if you are looking at the higher configurations, then you could program this using a 2-axis roughing as opposed to just a facing toolpath here.
Mm-hmm.
Now once we have the roughing program, the next step I would like to do is go ahead and pocket this feature in here. So I'm going to go over to 2-axis and select pocketing. I'm going to use select curve edge regions. And I'm going to pick the edge, the top edge of the pocket. I could even pick the floor, but in this case I'm going to pick the top edge. Now you'll see that the part region option is available in the Xpress. If you'd like to be able to pick a start point where you can actually model create a point in your part model, and you can use that as the point where you want to drill the hole, those options, additional options are available starting with our standard configuration. In the case of Xpress configuration, you can define your part region for pocketing. You can specify a tool for it, so I'm going to go with a 1/2 inch end mill, set the feeds and speeds, specify clearance, and now in the cutting parameters, you can specify your tolerances for roughing, specify a stock allowance, you can leave a wall stock, and you can pick between offset or linear cut patterns. Additional cut patterns are offered in higher configuration starting with standard. You can pick your cut direction in here, specify your step over, and in the cut levels, you can also measure the depth by selecting the top face and then the floor. Now if you'd like the depth to be automatically determined based off this 3D model, this option would be available in your standard and higher configurations. So in the Xpress, you can actually measure the depth by picking 2 points, and you can specify your depth work. And then you have the option to set your entry and exit parameters in here, and then pick generate. Now if you're looking for additional parameters like sorting or advanced cut parameters, those options aren't included in Xpress configuration. They're available starting with the standard configuration of the product. So we got the pocketing toolpath program. The next thing we're going to do is add a profile to finish that up. So we're going to pick the same edge, grab a tool for it, set the feeds and speeds, similar to what we did on the pocket operation. And here for the cut parameters, I'm going to put the stock to leave 0, pick a cut direction as climb, and in here I got to choose outside or inside. Since I want a profile on the inside, I'm going to use inside. Now with our higher configurations, the profile operation can automatically determine which side to place the cutter when determined using 3D model is selected in here. So we're going to use inside or outside in Xpress configuration. The next step is to specify your cut levels. Again, you can pick the depth in here by selecting the top face and then the floor. So you can pick 2 points to establish the depth. In the higher configurations, you have an option to automatically determine the depth based on the 3D model. And then you can set your entry and exit parameters and generate it. Now, additional options like advanced cut parameters and arc fitting and sorting are available with the standard and higher configurations. So there's your toolpath. Now, if the geometry you select is an arc or as a circle, then the toolpath arcs are automatically being fit to the toolpath, as you notice it in here. So the arcs are represented in dark blue and the linear motions in cyan color. Now we got the inside features programmed. The next step we want to do is program the outside features. We want to start by a roughing toolpath. So we're going to go to 3-axis and we'll start with the roughing cut. So we'll use horizontal roughing. Now for this operation, I'm going to contain the cutter between these two areas. I'm going to use select curve edge regions. First, I'm going to select the sketch, right click and select chain, or I could even select them from the feature tree in here. And for the next feature, I'm going to pick this edge on the pocket. So I want to rough between these two areas in here. I got those two regions selected. Specify a tool for it. Set the feeds and speeds. Establish the clearance plane. In the cutting parameters, you can specify your tolerances for roughing. You can specify the stock to leave, and you can pick between offset or linear pattern if you're working in cavities, and based on core regions, the system can automatically determine a core and a cavity. So when this is checked, it'll use a facing cut pattern for core regions. You can specify your cut direction, your step over in here. You can also control your cut levels, how fine you want the cutter to step. There's a lot of options in here when roughing. And you can specify your engage and retract parameters, and then pick generate. Now additional options like advanced cut parameters where you can perform smooth cut connections, arc fitting, those options are available starting with the standard configuration. And there's your roughing toolpath right there. We can now go into the simulate tab, select the operation, and pick play to run the simulation. You can always do a pause and then pick simulate to end to run through the simulation. Now since we picked the rectangle in here as a containment, you'll notice that the cutter stays up to the boundary, so it wasn't able to rough some of the areas out in here. Now if you'd like to go back and modify your sketch or containment, since you're working in a parametric system in here, I'm going to go ahead and edit the sketch in here. And I'm going to go ahead and resize it. You'll see that I'm going to modify the sketch, make it slightly wider in here. And I'm going to accept the changes, commit the changes. You'll notice that the operations that utilizes the sketch was automatically flagged as dirty in here. All I got to do is go back, right-click on it, and then regenerate, and the toolpaths would automatically be updated based on the changes we put in. So even with the Express configuration, if you make a change to design, you could go back and update your toolpaths. In this case, it was just a simple regeneration since I scaled or made the sketch larger in here. And now I can go back and run the simulation by selecting simulate until, so it'll simulate through all of the operations in here. So VisualCAM for SolidWorks is an integrated CAM solution for SolidWorks. So if you're working with SolidWorks, if you want to make a change to your design, you could go back and regenerate and update your toolpaths.
Uday, could you tell us the difference between the simulation models and the Express and the higher configurations? You
Absolutely.
might be wondering about that.
The Express configuration includes the voxel simulation model, which is our homegrown simulation model. Now this simulation model works great for 2 and 3 axis simulations. However, the resolution of the simulation is not very fine on the z-axis, so you would probably notice these artifacts in the simulation here. Now, starting with our standard configuration, we include the advanced simulation module where you can use between the voxel and the polygonal simulation, which gives you a much better rendering of the cut material simulation and the verification process. So with the Express, you get the voxel simulation, and starting with the standard, you get the advanced simulation model.
But this doesn't affect the actual toolpath, correct? I mean, it's just
That is correct.
display of the cut material.
Absolutely. Now we got through the roughing. The next step is we want to go ahead and finish off these, sculpted surfaces and radiuses on the part. So we're going to go back and generate the toolpath for a finishing cut. Now before we do that, you'll notice that there were some areas like these flat areas on the part where it left more material, and if you'd like to clean up the flat areas, you can always go back and edit your roughing operation, and in the cut levels you can select clear flats, and this will automatically clean up the flat areas right on all the flat faces in here. So I've set it to clean up the flat areas on each of these flat faces on the part, and you will see that once the toolpath is generated, it'll finish the you know, flat faces to the finished depth.
Yeah, I noticed you moved the top plane down so you didn't disturb that finished planar surface on
Yes.
the top. That's
Right.
I like that.
Under cut levels, you can use the containment in the Z to move the top plane. So I set it to 100 thousandths below the top face, which is Z0.
Mm-hmm.
The next step we want to do is do a finishing cut. We're going to do that by using a parallel finishing operation. So these are the two methods that are offered in the Express configuration. So in the case of parallel finishing, I'm not going to pick any regions in here. I'll use a ball mill. Typically radius cutters like ball mill and corner radius tools are ideal for it. So I'm going to use a 1/4 inch ball. Beats and speeds, I'm going to use load from tool. Clearance will be set to automatic. Under the cutting parameters, you'll see that the tolerances are set to 1,000 and the start to lead is set to 0 by default. You have your cut direction set to mixed, and you can also set your angle of cut. By default, it's set to 0, which means the tool path will be in parallel planes to the x-axis. You can change the angle of cut to any angle in here. In this particular case, I'm going to have it ignore all of the holes by selecting ignore holes. I'll put in a step over of 15% and then pick generate. So this basically generates your parallel finishing toolpath right in here, following a 3D model. Now the parallel finishing also offers additional options like Z containment in here. So for example, if you don't want it to cut below a certain Z, you can actually go ahead and pick that, and you can also change these parameters in here manually. So I could say I want to leave like 100 thousandths from the base of the part, and then go see that it'll automatically contain the toolpath to the specified Z level. Since we said ignore holes, the holes are being ignored automatically in here as well.
Could you ignore that
we
top face too?
Yes, we could. So we can go back into the parallel finishing, go into Z containment, and you could actually use a higher Z containment, and I can just go pick this point right in here,
Yeah.
and then generate it, and that'll automatically ignore the top face as well. There it is. And you can now go to your Simulate tab and run the simulation. There's your 3-axis parallel finishing toolpath. Now that is with the angle of cut set to 0. You could always do a pause and then simulate to end, and there it is. Now you could go back and change your angle of cut. So in this case, I'm going to make a copy and a paste. Right-click copy, right-click and paste. Edit the operation, double-click to edit, and then change the angle of cut and generate it. So in this case, it will change the direction of cut, so it will clean up any of the scallops that might be left with the cut pattern when the angle of cut was set to 0 degrees.
Mm-hmm.
And there it is. Now finally, you'd want to go ahead and chamfer this edge and then do a profile cutter on the part. So we'll go ahead and use 2-axis in engraving, and we can use engraving to chamfer this edge in here with a tool. It could be like an engraving cutter like a V-mill or a chamfer bit. So the Express configuration allows you to select a V-mill for chamfering. So you can use the engraving operation to engrave on this. So basically you're breaking an edge. Now if you want to use a chamfer operation, then that's offered in the standard configuration and higher levels. So you got to use like engraving to work around it to be able to program these features in here. And there it is. And then we would like to go ahead and drill the holes before we relieve the part from the stock. So we go to hole machining and drilling, and we can now select the holes. We can pick a flat face in here, or we can just select the top face edge on the hole feature. Specify a tool for it, so I'm going to go with a 1/4 inch drill. Specify feet and speeds, set the clearance, and in the cutting parameters you can choose the drill type, whether you want to do a standard drill, deep drill, countersunk, brake chip, or user-defined cycles. All of these options are available in the Express configuration. And you can measure the drill depth in here by selecting a top face and a bottom edge. And to make it a through hole, I can click on Add Tooltip for drill depth. If you'd like to have the option to be able to sort the holes, those options are not available in Expert, so you would have to look at upgrading it to standard or higher configuration for it. And there is your drilling operation.
Hey, Uday, before we wrap up, could you show them where the quick start guide is in case they download a demo and want to run through it? I believe you can get
Absolutely.
to it from the
So
menu there.
you would go to the Tools, VisualCAM menu, and go to Learning,
There it is, yeah.
and then you click on Quick Start to launch the Quick Start guide.
Okay.
And
Nice.
finally, we want to do a profile cut around it, so we'll go to 2-axis and profiling. And in here, I'm going to use, to drive region, I'm going to use select tangency in here to go select the entire loop around the part. Specify a tool for it, set the feeds and speeds, specify your cutting parameters. I'm going to choose cut on the outside, and then specify the parameters in here. And then you entry and exit, and then generate it. And there it is. There's your profile pass.
Also, I just want to mention real quick, you can set the colors of the cut material simulation, correct? In the CAM preferences?
You can change the color under CAM preferences.
Yeah, so that color is a little bit dark, a little bit difficult to see, but that's controllable also.
Yep. So you can go under color preferences and
Yeah,
you can make it lighter.
Yeah.
Now, one of the nice things we have in our higher configurations is automatic detection of whole features. So rather than having to go through the process of manually identifying and selecting it, there's a Features tab which can allow you to detect whole features. And you can also, if you're working with parts that have family of parts, you can save the whole features you identify into a knowledge base and automatically have those whole features be applied for parts that have exact same whole feature cross-section. So those options are available in the higher configurations. Now, once you have the toolpaths program, in the demo mode, you can take a look at the estimated machining time as well. It shows you how long it's going to take to cut it. Right-click on information. You can also generate what is called a shop documentation. So right-click and then choose shop documentation. And you can choose the template in here. And this will generate a setup information sheet, which would give you information about your tool, your cutting parameters, your feeds and speeds, the total time it would take to process each of these, cut each of these operations out. So this is a very useful tool for the operator in the shop floor to get things prepared for machining this part out. And it automatically displays this in your web browser. And there it is. There's your part right there, and you can see the total number of tools being used. And it includes information about each and every operation. It has your operation name, tool number, your cut feed rate, all of it right there.
That's nice, Uday.
Yep. Now, in the demo copy, you will not be able to save the CAM information to the SolidWorks part or post-process it. So, how do we register it? So once you purchase the product, you go into your, in the Get Started dialog, you can click on Activate Paid Product, or if you have the product running, you go into the License dialog. And in the License dialog, you enter in the activation code that's applied to you, and then you pick Register. Now once you have it registered, you will now be able to post-process it out to your machine tool. And your posted output file automatically appears in your text editor. You can see your work offset number, your tool calls in there, your spindle speed output. All of this is in your posted output file. And now saving your work in SolidWorks will automatically save all of the CAM information with the part.